we apply the break-even analysis on a dry cleaning business. So a dry cleaning business is looking for a new location to expand their business. They identified 4 locations. These 4 locations are called A, B, C, and D. For each of these locations, they already identified the annual fixed cost and the variable cost. Though the annual fixed cost probably are related to the rent payment. Though location A has a very high rent payment, but you also see that the cost per unit are very small. So what is a unit in a dry cleaning business? It could be something like 1 kg of textiles or whatever. Yeah? So the unit costs in location A are quite cheap, but the fixed costs are quite high. The other data is given here for location C. You see they have the highest variable cost. Now our task is to plot the cost curves of all 4 locations. So we will have 4 cost curves which are straight lines, and then we should identify which is the best location if we expect to sell 10,000 units. Of course, what we also could do, if we think the 10,000 units are very reliable, we just calculate for each location and 10,000 units the total cost and make our decisions based on this total cost value. We choose a location with the total cost. However, it does not give us much more insight. It only gives us the best location with the lowest cost, and we have no idea what might happen if this demand, this forecast, is not exact and we only sell 8,000 or maybe more, like 12,000 units. Okay, let's draw the cost curves. For each straight line, we need to identify 2 points. One point can also always be a sales volume of 0 units, so our sales quantity is 0. Then the first point is always equal to the fixed cost. And the second point, here since we expect or we hope to sell 10,000 units, let's take just 10,000 units. You could also just take 1,000 or 100,000. Try to choose a realistic value, but the curves will be the same in the end. But maybe you make your life easier with drawing the curves when you use an appropriate value. So how did we calculate this total cost volume? So the total cost are the fixed cost plus the variable cost times the sales quantity. So for location A, 350,000 times the variable cost 5 Omani Rials times 10,000 units. We repeat this for the other locations, and now we have 2 points to draw the straight line for each location. Though for location A, at a quantity of 0, this is here, the total cost are 350,000, and for a quantity of 10,000, the total cost are 400,000, which is here. So then we can draw the cost line for A. And we do this for all the other locations in the same way. When you make this drawing, do not forget to indicate which line represents which locations. It can be easily confusing, as you can see here. So this is the line that represents the cost for locations, for location number C. And on the x-axis, we have the quantity that we can or hope to sell. So if we sell 2,000 shirts, for example, if we clean 2,000 items, Then we are here, 2000 items, and we go up until we reach the first straight line. And this is the line that represents the location C. So that means if we think we will sell 2000 units, then we should go for location C, because this is the location that offers us the lowest cost, the lowest total cost for this amount, for this sales volume. If we think we might sell 6,000 units, 6,000 units is here, then we go up until we reach the first straight line, and this is the line that represents the total cost of location B. So in case we think we will sell 6,000 units, then it makes more sense to go for location B. And the same for location A. If we sell more than 10,000, if we sell 10,000 units, we should choose location A. What you also see, location D will never be chosen, though we can get rid of it immediately. So to sum up, location D is never the best. Location A is the best when we sell more than 9,000. We can see this 9,000 from the drawing. And location B is the best when we sell less than 9,000 and roughly more than 4,500 units. So how can we now calculate the exact point when location B is better than location C? What is the exact quantity where B is superior to C? How to do this? We need to calculate the intersection of the straight line C with the straight line of B. So the total cost of location C are 100,000 plus 40Q equals the total cost of location B, 170,000 plus 25Q. When we solve it for Q, then the precise quantity where both locations have equal costs is at 4,666.67 units. So this is this quantity, 4,666. We can repeat the procedure to identify at which quantity A is better than B by setting the total cost of B equal to the total cost of A, solve it to Q, and the result is 9,000. So by doing it this way, we have precise sales quantities that give us an indication which location is better depending on the sales quantity that we can expect. And in particular, when we are thinking about selling 10,000 shirts, this value is also a forecast. So depending on how sure we are that we can sell 10,000 units, we can choose our location. When we are very clear that we will sell 10,000 or even more, then of course we should go for A. But if we are not very clear about this and are a little bit more cautious, then maybe B might be the better location if we think that our sales quantity is somewhere between 4,600 and 9,000 units. Okay, to sum up this whole chapter on location analysis. Location analysis is about choosing the best geographical location for a facility. We are often doing capacity and location decisions together. They depend on each other. There are 3 basic steps to assess a location. First, we need to find out what we want. What are the factors that impact the quality? Then we need to identify potential alternatives of locations. And finally, we evaluate these alternatives. The key factors in location analysis are usually the proximity to customers, suppliers, or labor sources, and transportation considerations. For the third step of this three-step procedure, the evaluation of the alternatives, we extensively studied 4 methods. These were factor rating, load distance model, center of gravity approach, and the break-even analysis. And you should be able to apply these methods on your own in order to support location decisions.